Hello and welcome to lesson 1-5 on midpoint and distance. We're going to start off by looking at midpoint, and midpoint is exactly what it sounds like. It's the point that lies exactly halfway in between 2 points. So first we're going to look at the points 2 and 8 on the number line. The point that's directly in between them is 5. Y'all could probably see that just by looking. But what if I wanted to get it without the number line? Well, the midpoint is always the point that's the average of your 2 points. So 8 plus 2 over 2 gets me 10 over 2, which is 5. So it's the average. And there goes my lead. Sorry, guys. It's the average of the endpoints. All right. Now, if I want to find the distance between 5 and -7, well, distance is the absolute value of the difference of these 2 points, -5 minus 7, which would get me the absolute value of -12 or 12. Now, distance must be positive because it's a length. We cannot have -3 inches. But midpoints can be negative. Now, the midpoint is going to be the average of these two. -5 plus 7 over 2. That would be 2 over 2, which is 1. And I could even check myself on the number line. -5 and 7. The middle number here is 1 because it's 6 away from 5 and 6 away from 7, so it works. I want you to do the next one on your own and show it to me in your notes tomorrow. Now, given the midpoint and an endpoint, could we find the missing endpoint? Well, we could, because again, the midpoint is the average of your 2 endpoints, plus endpoint 2 over 2. So I'm going to plug in. My midpoint is -5. One endpoint is 6. I don't know the other endpoint. Over 2. Multiply both sides by 2 to get rid of the fraction, so those would cancel. Then I have 6 plus the missing endpoint is equal to -10. Subtract 6 both sides, and my answer is -16. We can extend this into the coordinate plane pretty easily, actually. I've already plotted the points on my graph, 5, 3, and -3, 3. And all we have to do to find the midpoint is to consider the x values and the y values independently. So my x values are 5 and -3. So 5 and -3. The midpoint between them, 5 plus -3 over 2, 2 over 2 is 1. If I look, it's exactly halfway between them, so that works for me. Now my y values are 3 and -3. So 3 and -3. The midpoint between them is clearly 0, but just to show you that it works with the math, 3 plus -3 over 2 equals 0 over 2, which is 0. So the coordinates of my midpoint are 1, 0, which if we plot is on the line that I drew, so I know it's correct. And if I look, yeah, it looks to be about halfway. So if I was going to make a formula to represent this, well, I'm going to let my midpoint be represented by xm, ym. And to find the x value, we simply added the 2 x values together and divided them by 2. And we did the same thing with the y. We took our 2 endpoints for the y values, divide them by 2. And that is my formula for the midpoint of a segment. Now let's do an example together using that formula. Okay, I have the point 2, -1, and the point -4, 5. And I want to know what the midpoint is between my 2 points. So what I'm going to do, I'm going to look at the x values first. I have an x value of 2 and an x value of negative 4. So I would do 2 plus negative 4 over 2, which is going to get me negative 2 over 2, which is negative 1. So that's xm. Then look at the y values. Ym. I have negative 1 and 5. Negative 1 plus 5 over 2 gets me 4 over 2, which is 2. So when I plot negative 1, comma 2, oh, I'm really happy because that's on that line. So I know I found the midpoint of that segment. I want you to do the next two on your own. And guys, don't be afraid of this one. It just has ugly numbers. You know, just you have to do fractions. Not fractions, decimals. So sorry, but have fun. Now, what if they give me a midpoint and then an endpoint of the segment that midpoint is on? How do I find the missing endpoint? Well, I'm going to use my formula. xm, ym is equal to x1 plus x2 over 2 and y1 plus y2 over 2. In the problem, they give me the xm and the ym. That's my midpoint. And then they give me the first point, x1, y1. So I'm just looking for the missing endpoint. I'm going to break this into two things so I can handle it more easily. My xm is equal to x1 plus x2 over 2. I'm going to fill in what I know. xm is negative 2. x1 is 9. I don't know the second endpoint. Now I'm going to solve. Multiply both sides by 2. So I get negative 4 equals 9 plus x2. Well, subtract 9, and I get negative 13 equals the second endpoint x value. Do the same thing for the y's. Ym equals y1 plus, not x, but y2 over 2. Plug in what we know. Ym is 3, y1 is 5. I don't know the second y value. Multiply both sides by 2 to get rid of the fraction. So I get 6 equals 5 plus y2. Subtract 5. So we get 1 must be my second y value. So my missing endpoint is at negative 13, comma 1. And that is my answer. All right. And brief summary, midpoint formula, and just know the midpoint is exactly halfway between the endpoints of a segment. Now let's talk distance. We already know that the distance between 2 points on a number line is simply the absolute value of their difference. Because again, distance can't be negative. Now what if I want to get the distance on a coordinate plane? Well, the easiest way to do that is probably to use Pythagorean theorem, and you guys are experts at Pythagorean theorem after many years of practicing with it in middle school. So what I'm going to do, I'm going to turn the points I've plotted, the segment I've plotted, into a right triangle by drawing straight down and straight across. Now again, I've got the points 5, 3, and negative 3, 3, and I'm going to call this side C, because that's the side I don't know. Now, the length of this side is the absolute value of 3 minus negative 3, it's 6. And the length of this side is negative 3 minus 5, which gets me 8. So, using my Pythagorean theorem, I'd have 6 squared plus 8 squared equals c squared. That's 36 plus 64 equals c squared. 100 equals c squared. Take the square root of both sides. 10 is the length of that hypotenuse, and so 10 is my distance between the 2 points. Length and distance are the same measurement. All right. I'm going to let you guys do these next 2 to practice. Okay, just because I don't want y'all to have to spend all night watching this video. And let's talk about how we could generalize this. Now let's say I've got 2 points x1, y1, and another point up here, x2, y2. And let's say I want to find the distance between the 2 points. Well, we've already talked about that the easiest way to do that is to turn it into a right triangle. And so that's what I'm going to do. I'm going to turn it into a right triangle. And we've got A, B, and C side. Well, I'm going to call this side C. That's the side I want. This is the distance. To get the length of this side, well, that's the absolute value of the difference between the x values. That's the length in the x direction. x2 minus x1. To get the horizontal length, well, that's the difference in the y direction. So it's just y2 minus y1. So if we write our formula out now, we've got that c squared equals the absolute value of x2 minus x1 squared plus y2 minus y1 squared. Now, squaring something will make it positive, so my absolute value signs are really no longer necessary. So I can just turn these into parentheses. Plus y2 minus y1 squared. And I want to solve for c, so I'm going to go ahead and take the square root. So I get c equals the square root of the difference of x2 minus x1 squared plus y2 minus y1 squared. This is my distance formula. So distance is square root of x2 minus x1 squared plus y2 minus y1 squared. We love it. It's our best friend. It's really easy to use. I highly recommend knowing it. It's all over the SAT. It's a good thing because sometimes we'll give you really hideously ugly numbers. Now here, I don't know about you, but I don't want to find 22 on my coordinate plane. So I'd rather just use my distance formula to do this problem. So what I'm going to do, I'm going to set it up. Distance equals x2 minus x1, 12 minus negative 12 squared plus y2 minus y1, 22 minus 15 squared. So we're going to keep going. 12 minus negative 12 is 24 squared plus 22 minus 15 is 7 squared, which will get me 24 squared is 576 and 7 squared is 49. When I add these together, I'm going to get the square root of 625, which I know is 25. So my distance equals 25. Now I want you guys to go ahead and do the next two on your own. Now just one last little note. We can extend this into 3 dimensions in a 3-dimensional coordinate plane. If you are seeking honors credit, this would be a good thing to take a look at. But otherwise, it is not required. I just wanted y'all to know that it's possible. Thank you very much, and I will do a second video with some answers to these your turn questions to be found online as well. Thank you. Bye.